So we have studied the 7 layers of the OSI model, but please remember that OSI is a reference model. It's a reference model, or it's a reference model that was given by ISO in I think 1984, the International Standards Organization, or you can think of it as a theoretical model. This is what researchers thought is a good base model on which real world models can be based on. The most widely used model in practice, so you can think of it as a reference or a theoretical model, while TCP/IP model is it's a practical reality that we work with on day-to-day basis. Most networking systems that we encounter today follow the TCP/IP model. Remember, the fundamental difference here is this is a reference model or a theoretical model that researchers proposed, which the International Standards Organization agreed after a lot of back and forth in the 1970s and 80s. The TCP/IP model is the most widely used practical model, right? So in TCP/IP model, again, in TCP/IP model, you have only 4 layers, broadly speaking. What they have done here, again, there are a lot of similarities between OSI and TCP/IP model. For example, these 3 layers are grouped together into just one layer called as the application layer. So you can think of TCP/IP model as a much more simplified, realistic, practical model. Because remember, again, this goes to that idea that I discussed with you earlier, right? For example, I told you earlier when we were studying OSI model that a real process or a real software like a browser handles all 3 of them, right? A typical system like typical software like a browser takes care of it uses the application layer, presentation layer, and session layer, and it works with all 3 of them. So in TCP/IP, people said, why do I need 3 layers? Why should that confusion be? Right? Why should that confusion be? Why can't I just call this whole thing as application layer? And it's called application layer because applications or software or processes talk with this layer. It communicates with this layer and everything flows through. So they said, okay, but again, remember the application layer here does everything that these 3 layers do. We saw what application layer has these protocols like HTTP, HTTPS. Actually, we talked about DNS in the previous video, right? DNS is also one of the protocols in the application layer, right? DNS, HTTP, HTTPS, SMTP, all of them are application layer protocols. Then there are some tasks at the presentation layer. The session layer ensures connectivity, sessions, SSL, security like SSL. There is also a more modern version of SSL called as TSL, right? So the question here is, where does SSL fall into? Should I place SSL into my session layer or presentation layer or application layer, right? Again, because security is important. Security is also enabled through your HTTPS via using everything else. So in TCP/IP model, people said, let's simplify the whole thing. Let's just call these 3 things as application layer. This application layer will perform everything that these 3 layers perform, right? So, and the unit that we work with here is your data. It's a raw data. Till now, we don't have segments, packets, frames, none of it. The unit that I work with in the application layer is called my data, literally my data, right? This is my layer 4 here. Then they said, okay, let's not touch the transport layer because it's very, very neatly organized. Similarly, let's not touch the network layer. Right? So in TCP/IP model, in the transport layer, we use protocols like TCP and IP. In the network layer, we use IPv4, IPv6, etc. So a unit of data in the transport layer, again, the transport layer in the TCP/IP model does exactly what the transport layer in the ISO does, right? And you have the concept of segments. Again, sometimes the segments are also called as datagrams. Okay, some older books use this term called datagrams. Okay, the network layer here does the same job as the network layer here, and the unit of data is called as packets. We have discussed about segments and packets in the previous videos. Now here at the very end, instead of having 2 layers here, why can't I just call it as the physical layer? Because this is where the physical hardware is coming into play. My Ethernet cables, my radio signals, my translation of bits to electrical and into fiber optic signals, into radio signals, all of that is happening here. So instead of having 2 layers here, let's just call it physical layer here. But physical layer has data in 2 levels. Look at this. the physical level, again, this is your level 3, your level 2, your level 1. Your data link layer has frames. Remember, your data link layer has frames. Your physical layer literally has a stream of bits, which are either represented using electrical signals or light signals or radio signals. So the physical layer here has two parts, right? The physical layer will have bit stream at the lower granularity, and it will have frames, right? So if you think about it, your TCP IP model is a simplified real world practical model, which is heavily based on the OSI model, which is based on the reference that was provided by OSI model. But TCP IP model simplifies everything for you. And it only has 4 layers, thereby simplifying the whole application development, simplifying how you think about it. Okay, that's very, very important. So we will, as we go forward, we will study about all these 4 layers. In some instances, we'll break down these layers also. We'll study physical layer and data link layer separately. Because there are some specific aspects that if you want to study deeper, we could go into this, right? So TCP IP model in its very core is nothing but a practical version, a practical and simplified version of the OSI model, which is actually used in practice, right? And whenever I say a word segment, please understand that I'm talking about the transport layer. Whenever I use the word term, when I use the term packet, I'm talking about the internet layer, right? Or the network layer, or the internet protocol, which is often used here. Whenever I'm saying frames, I'm in the data link layer, bitstream, again, physical layer. When I say data, I'm in the application layer, broadly in any of these 3 layers, right? That's how the mapping works.